everyone, we are the computer engineering students of BSCPE 2A from Eulogio Amang Rodriguez Institute of Science and Technology, Manila. Hi, my name is Jericho Bicelo.
My name is Roland Adrian C.S.com.
Hi, my name is Randall Joshua Manguba.
And today, we are about to give you a tutorial of ISM or Incremental Search Method. So first, let's proceed to the meaning of the ISM or Incremental Search Method. Incremental search method is a numerical method that is used when we need to find the interval of two values of x that is meant to contain at least one root. It is also the most basic automated numerical method that is used for solving nonlinear equations.
So, the purpose of incremental search method is to determine an approximation of some initial values that were going to be used to calculate roots and to locate where iteration ends.
Here's our equation. 2x cubed plus 4x squared minus 4x minus 8. First, we need to separate the different terms and get the absolute value of them. And we will get 2x cubed plus 4x squared minus 4x plus 8. Factor of the first term will be 2x squared times x plus 2 minus the factor of the second term will be 4 times x plus 2. 2x squared minus 4 times x plus 2 since they have the same multiplier. And then both sides divide by x plus 2. And then we will get 2x squared minus 4 is equals to 0. Transfer the negative 4 to the other side and then both sides divide by 2. X squared is equals to 2. Square root both sides, so therefore the value of x is 1.414.
In our table, we will use graphical equation method. We will substitute the x's in our equation. If we substitute 0, we will get negative 8. If we substitute 1, we will get negative 6. If we substitute 2, we will get 16. And if we substitute 3, we will get 70. So now, we will use negative 6 as our lower limit and positive 16 as our upper limit because our root is between these two. So now we will make our table. For our first iteration, we will use 1 and 2 because our root is in between negative 6 and 16. Now, we will use 1 as our lower limit and 2 as our upper limit. In step, we will use 0.1. To find the value fxi, we will substitute the lower limit to our equation. So now we will get negative 6. For the fxn, we will use our upper limit as well. So, if we substitute it, we will get positive 16. After that, we will multiply fxi and fxn so that we will get negative 96. Now, this is our full table. There is a root, which is at the last iteration. We notice that in the fxi and in fxn has a changing of signs. There's rule which if there's changing of signs, we will add decimal place at the step column. If there's no changing of signs, then we will use 0.1. If there's changing of signs, we will add decimal place. Like this, there's a negative and a positive, so that we will add decimal place. And another one, there's a positive and a negative again, so then we will add decimal place. For the xi and the xn, just copy the previous xn and then write it in the xi. So the next xn, we will add 0.1 from the step column to the xn, so that 1.2 plus 0.1 is equals 1.3. We will use those process until we reach the initial root in the xn.